All right, in this video, we're going to learn about how to add and subtract radicals. Okay, so for number one, we are going to have root 3 plus root 3. How do we add these? Now, when you think about this, I want you to think about it like a variable and a variable. Root 3 is like an x, and this other root 3 is like another x. And when we add x plus x, what do we get? We get 2x. Now, this isn't actually x, and this isn't actually x, but it would be, right? So instead of the x, we're just going to replace it with a root 3. So 1 root 3 plus another root 3 equals 2 root 3s. So really there is an invisible one out in front here. Let's try another example. So let's say we had root 3 plus root 2. Well, okay. We have to find another variable. Let's say that root 3 is an x, okay? And let's say that root 2 is y. Well, in this case, x plus y can't be simplified any further because those are not like terms. And in the same way, root 3 and root 2 are not like terms. They can't be added together. They're not of the same kind. So we just keep them just like they are, and that's the answer. Can't add them together. They don't mix. Okay, number 3. Let's say that we have now a root 2 plus a root 8. Now you might be tempted to say, oh, we can't do this because they have different numbers under the radical. However, not so fast. We can simplify root 8. We know how to simplify that because it has a perfect square in it. That would be the 4. So it would be 4 times 2. And you take the square root of 4 and you get 2. This simplifies to 2 root 2. And then there's your root 2 coming down right there. So we've got 1 root 2 plus 2 root 2s. And we can add this. Remember, we think of this like kind of like an x, right? And then we would think of this as like 2x, right? So what's x plus 2x? Well, that's 3x. In the same way, we have 1x plus 1 root 2 plus 2 root 2s is 3 root 2s. And sorry, the announcement's going right now, of course, while I'm making my video. But that's okay. No worries. They have to repeat it. All right, so in this next problem, we're going to be adding root 12. And there's a jet taking off. Oh, this is great. Okay, root 12 plus root 12. And you might want to just say, oh, well, 1 root 12 plus another root 12, and that's 2 root 12s. Well, that would be true. However, we can simplify to root 12. Why? Because 12 has a perfect square in it. So in this case, the right thing to do would be to add them first, then simplify. You could simplify the root 12 here and the root 12 here. That would be 2 simplifications and then add it, but I think it makes sense to just add it first and then simplify. So root 12, like I said, has a perfect square of 4 in it. And then you've got the 3, 4 times 3. You take the square root of the 4, and then you've got 2 times the 2 that came out, and then the 3 is left inside the square root. So that equals 4 root 3. And we're done with that one. Okay, all right, let's try another one. So let's try root 12 for number 5 here. Root 12, or no, 2 root 12. 2 root 12 plus root 3. So this is an example of one we're going to have to simplify one of them, which can be simplified like we just did. And then we are going to have to add it to the other one. Now, we already figured out in the last problem that 2 root 12 simplifies to 4 root 3. So I'm just going to use that knowledge and cheat and just write 4 root 3 right here, because that's what I know it is. You may be able to get good enough at this to just do that in your head, but 4 root 3 plus root 3 is, well, remember, this is like 4x plus 1x. What's that? That's 5x. Or 4 root 3 plus root 3 is this 5 root 3, okay? So that's our answer, 5 root 3 for number 5. Okay. Now, what if you have a problem that looks something like number 6, where you have a root 15, which cannot be simplified, plus a square root of 225, which can, plus a square root of 3 in this case. All right, what do you do in this case? Well, this 225 right here is a perfect square, so we can just take the square root of that. Like I said, though, the 15 cannot be simplified, or the root 15 can't be. So square root of 225 we know is 15, and then we can't simplify the square root of 3. Okay, well then now what do we do? Well, we actually can't simplify this anymore, but we're going to write it in the correct order. Okay, so we're going to write it like this. The number goes first, okay? That goes first. And so we'll write that. Plus the bigger root goes next if you got, if you got roots, that is. And then the smaller root right there. And that's actually your answer. You can't simplify it anymore. So there you go. Okay, now we're going to move on to subtracting radicals. So here we go. Number 7, I believe it was. So number 7, we got root 8 minus root 2. Okay, so that looks maybe like something you can't do. However, you can simplify this root 8. How can you do that? Take the square root of 4, and then you leave the 2 in there. Square root of 4 is 2, goes on the outside, 2 stays in. We can do this one. 2 root 2's minus 1 root 2 is 1 root 2. Okay, and there is an invisible 1 there. I don't write it, though. There's our answer. Okay, number 7. Number 8 now. We got root 3 minus root 12. Root 3 minus root 12. Okay, so we can't simplify the root 3, so we'll leave that right as it is. The root 12, though, we can simplify. Has a square root of, or a perfect square of 4 in it. So we will take that out and take the square root of the 4. It goes outside. That's a 2. 4 goes away. 3 stays in. Boom. Okay? That's how we do that. Now, we have 1 root 3 minus 2 root 3's. That means we got negative 1 root 3's, or just negative root 3. Same thing. Number 9. 2 root 2. 2 root 2 minus root 8. Okay? Well, we know that root 8 up here simplifies to 2 root 2. So I'm going to cheat a little bit and just write 2 root 2 instead of root 8. So then, folks, what is 2 root 2 minus 2 root 2? Don't get confused now. Maybe some of you go, oh, well, it's 0 root 2. Well, you'd be right. But that equals 0, because 0 times anything is 0. And we're done with that one. Number 10. How about this? And this is our last one for today. We got negative root 2 minus 2 root 8. Okay. Well, then how are we going to do this one? Well, first we need to simplify whatever we can, which is the 2 root 8. Why don't you try this one on your own? So we can't simplify the negative root 2, but the root 8 simplifies to a 2 root 2, as we know, right? So 2 times 2 root 2 is a 4 root 2, so minus 4 root 2. So negative 1 minus a 4, we have two negatives like that. We're adding them together, so that means we got a 5 root 2, but it's all negative. And we're done with that one, negative 5 root 2. And that's how we add and subtract radical expressions.